This is Formal Lab 3 by Shannon Hilborn, Shay Oswald, and Legend Kenny. So for the start with our lab, we wanted to look at the absorbance spectra of dyes and the fluorescence of dyes. In the first part of the lab, we were given an unknown dye and had to find its absorbance spectrum to determine which dye it was from, given the two dye absorbance spectras that we were given. In the second part of the lab, we were given the fluorescein dye. Using the dye, we had to find its absorbance spectrum and its fluorescence spectrum. So for the first part, we wanted to focus on absorbance, and absorbance is a measure of how much light is absorbed in a given path of length. And our goal is to find the absorbance pattern of the unknown dye. The absorbance graph of the dye was then compared to the two known dyes. For the second part, we wanted to focus on fluorescence. And fluorescence is the process of how molecules can have their electronic states excited and produce light as these molecules return to lower energy states. The goal, graph the absorbance spectrum of the fluorescein and the fluorescence spectrum of the fluorescein. In part 2, we used fluorescein. This is a green dye that is used in planes. If a plane were to crash in a large body of water, the water around the crash would turn green due to the fluorescein. In our experimental design for part 1, the flashlight and the wand of the spectrophotometer were both taped down to the table. First, we placed a cuvette with water and its intensity per wavelength by placing it in between the flashlight and the wand. Next, we were given a cuvette with the unknown dye and found its intensity per wavelength by also placing it in between the flashlight and the wand. For part 2, the flashlight and the wand of the spectrophotometer were both taped down to the table. First, we placed a fluorescein cuvette in between the flashlight and the wand. This allowed us to find the intensity per wavelength. Next, we had to reposition the flashlight so it was not now perpendicular to the cuvette, which allowed us to find the fluorescence spectrum. So for relevant models, we need to know what an electromagnetic wave is. An electromagnetic wave consists of an alternating electric and magnetic field, which you can see to the right. So these waves can be affected by mediums, and mediums cause a magnetic interaction causing the wave to be affected. Different permeabilities cause different change to the wave, which can be measured. Since certain properties can't change within a wave, such as frequency, frequency has to remain constant due to the law of conservation of energy. So this means that the speed/wavelength change. The change in the speed/wavelength can be measured to identify the medium that the light passed through. So for the first part, we found these graphs on the right, and the top one was given to us. So we used the intensity and the data we found for the water cuvette and the unknown dye cuvette to find the absorbance spectrum for the dye. The intensity data of the dye cuvette was subtracted from the water cuvette intensity data to find the absorbance spectrum for the unknown dye, which gave us this blue graph on the right. The graph we found via our data closely matches the Lapidus dye absorbance spectrum that was given to us on the top right. The expected curve on the absorbance spectra should not have any negative values. Our curve showed some, likely because it picked up some outside light from the classroom. For the second part of our lab, we found the data, and these graphs gave us the blue line, which showed us the absorbance spectrum of the fluorescein. This was found by taking the intensity data from the fluorescein and subtracted from the water intensity data from the part 1. The result of that is the blue line on the graph. After the first peak on the blue graph does not completely match the given graph above. This is because of the wand spectrophotometer likely picked up some outside light again from the window. The red line in the graph is the fluorescence of the fluorescein. This data was found by putting the flashlight in a different position, which was perpendicular to the cuvette and the wand of the spectrophotometer. The data we found for this closely resembles the given graph. The right side of the peak on our graph is not quite as low as it should be, but again, this is most likely due to the wand picking up some outside source of light from the classroom. So these are how we set up our experiment. So for part 1 and 2A, we had them set up directly across from each other with the cuvette in the middle, and then to find the fluorescence spectrum, we had the flashlight and the fluorescein cuvette directly perpendicular to find that fluorescence spectrum. So some possible errors that we didn't have many, but the two that I think we had were there was some slight inconsistencies in our dye, and we believe that most of the error in our lab were due to the outside light sources in the class. And that is our presentation, and thank you for listening.